Hello class, today we are going to look at properties of parallelograms. So before we talked about properties of polygons in general, today we are specifically going to talk about parallelograms. So the first question is, of course, what is a parallelogram? And a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So you see here, this side is parallel to that side. This side is parallel to that side. That's what these arrows mean, right? So both pairs of opposite sides are parallel to each other. So let's take a look at this and see what all we can do with that. All right. So here we go. We have a parallelogram ABCD here. We are given the measure of angle A. We want the measure of the other three angles. So what we know is that both pairs of opposite sides are parallel to each other. So since segment AD is parallel to segment BC, we can use this transversal here. We've got a transversal that's cutting two parallel lines, so we've got those different angle relationships, alternate interior, alternate exterior, same side, those things, right? Well, if we look at this, angle A and angle B, those are same side interior angles, right? And as we remember from way back before, if you have same side interior angles with parallel lines, then the angles will be supplementary to each other. So that means they add up to 180, right? So what we can do is 180 minus 80 equals 100. So the measure of angle B is equal to 100 degrees. We'll go and write that here, 100 degrees. Okay, so what's the measure of angle D? Well, angle D, let's see here. From angle A, we've got this transversal, AD, cutting two parallel lines again, right? Same thing. So once again, we have same side interior angles, so they will be supplementary to each other. So 180 minus angle A of 80 degrees equals 100 degrees again. So equals 100 degrees. 100 degrees. There we go. Okay, so now what about angle C? Well, you know what? Angle C, we've got parallel lines cut by a transversal again, don't we? And so, once again, we have same side interior angles, which are going to be supplementary. This time we're going to be supplementary to 100 degrees. So let's see here. That's 180 minus 100 equals 80 degrees. So angle C is equal to 80 degrees. And so looking at this, what do we know? What can we say in general about parallelograms? Well, since those opposite sides are parallel, that means that these consecutive angles, angle A and angle D, angle A and angle B, those consecutive angles there will be supplementary. Consecutive angles of parallelograms are supplementary. The measure of angle A plus the measure of angle B will always equal 180 degrees every single time. Remember, consecutive means right there next to each other. So the consecutive angles, the angles that are right there next to each other, will always add up to 180 degrees because there's same side interior angles between two parallel lines. Right? Other thing we can talk about, though, if you'll notice, look at that right there. The opposite angles, you'll notice, are the same thing. And that's always going to be the case because if angle A is supplementary to angle B because they're consecutive, and angle C is also supplementary to angle B because they're consecutive, then angle A and angle C have to equal the same thing. So this gives us another theorem that we can use, the parallelogram opposite angles theorem. And what this says is that opposite angles of a parallelogram are congruent. So angle A is congruent to angle C, angle B is congruent to angle D because they are opposites. All right, so let's take a look at some other things. That takes care of angles. Let's take a look at this. So here I have this parallelogram ABCD, and I've drawn the diagonal in it. So let's just take a look at things that I know about this right? Obviously, it's a parallelogram, and so I know that the opposite sides are parallel, but I've got this other line here, right? And because I have this other line, that tells me some things. Because these are parallel, I know that angle BAC is congruent to angle ACD. That would be this angle here, congruent to that angle there. Why? I've got parallel lines cut by a transversal, right? I've got this parallel line and that parallel line cut by the transversal that is the diagonal of my parallelogram. And so I, once again, have alternate interior angles. So this alternate interior angles theorem says that these two angles are congruent to each other. All right, well, what else do I know? I know that angle B is congruent to angle D. Right? Angle B is congruent to angle D. How do I know that? I know that because, as we just said, opposite angles are congruent. Parallelogram opposite angles theorem. And you know what? Looking at these two triangles that I have here, segment AC in one triangle is congruent to segment CA in the other triangle. Why? They're the exact same segment, right? That red segment is the red segment, so it's congruent to itself. And as you remember, that's called the reflexive property. So what I now have, look at that. Look at my two triangles there. Those are congruent now, aren't they? Yep, I've got three sets of things congruent. So those two triangles, those are congruent to each other, in this case by angle, angle, side. And if the triangles are congruent, what does that mean about these other two sides of my parallelogram? BA and CD, BC and AD. Yeah, if the triangles are congruent, then everything about the triangles are congruent. That means that segment AB is congruent to segment CD, segment BC is congruent to segment AD by CPCTC. Corresponding parts of congruent triangles are congruent. And so what I now know, I know that this is congruent to that, and this side is congruent to that side. So look at this. What does that mean about the sides of my parallelogram? Every single time, this means that the opposite sides of a parallelogram are congruent to each other. And that's nice to know. That is useful. We can use that for lots of things. All right. So parallelogram opposite sides theorem. And what this is that the opposite sides of a parallelogram are congruent to each other. So segment AB is congruent to segment DC. Segment BC is congruent to segment AD. All right, so let's take a look at one more thing. What if I draw both diagonals on there? What can we say there? Can we get some congruent stuff going on here? Well, let's see here. We know some things already. Once again, I already know that segment BAC is congruent to ACD because of alternate interior angles. That's the same angle I had a minute ago. That angle congruent to this angle. All right. What else do I know? Well, I also know these two. I know that angle ABE right here is congruent to angle EDC right here. Alternate interior angles going between the other parallel lines. Right. Not using the entire angle ABC because it got divided by the diagonal. So I'm not using the whole angle here. I'm just using the angles inside two triangles. And you know what? Segment AB is going to be congruent to segment CD. Why? That's right, because opposite sides of a parallelogram. Parallelogram opposite sides theorem. So these two sides are congruent. So now look at these triangles. We've got three pairs of parts congruent, and that gives us congruent triangles. In this case, our triangles are congruent by angle, side, angle. And once again, just like we had before, if the triangles are congruent, then that means those other two sides are also going to be congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So what that means is BE is congruent to ED, and AE is congruent to EC. Actually, I have three. All right. So looking at this, what this means is that the midpoint there, E, in the intersection, bisects both of those diagonals. And this is the parallelogram diagonals theorem. What that says is the diagonals of a parallelogram bisect each other. All right, now, notice what this does, this cuts the diagonals in half. This half and this half, those are the same. All right. AE and EC are the same. It does not mean that the diagonals are congruent to each other. It just means that E is the midpoint of both diagonals. All right. Okay, so let's take a look at this. Let's do a couple examples real quick here. So we're going to find the value of each variable in the parallelogram. Okay, so it gives us some expressions about the sides of the parallelogram. So what do we know about the sides of the parallelogram? Yeah, that's right. Opposite sides of a parallelogram are congruent. So we can just set this up. We can do it. See here. So we've got 4x is equal to the opposite side, which is y. And we can't solve for that, can we? Because that has two variables, and we can only solve for one variable at a time. So let's just leave that there. Let's look at the other two sides. So we have x plus 18 equals 3x minus 2. All right, that we can solve because we only have the one variable. We just have the x. So let's get all of our x's on the same side. So it's minus x there, minus x there. Okay, so over here we have 18. And 3x minus x is 2x minus 2. Got to move that 2 over, so plus 2, plus 2. And so we have 20 equals 2x. And if 20 equals 2x, we divide by 2. And then x equals 10. All right, so that is our first solution. X equals 10. And you know what? Now that I know what x is, I can plug that in over here. So we will have 4 times x, which I now know to be 10, equals y. Well, that's easy enough. 4 times 10, that's 40, and 40 equals y. There we go. Done. Because the opposite sides of a parallelogram are congruent to each other. Let's do another one. What do we got here? Okay, so here we have stuff with sides and stuff with angles. So I know the opposite sides are congruent, so that would be 4x minus 3 equals y divided by 5. And again, I got an x and a y, so I can't solve that right now. Now let's see here. So let's take a look at our angles. Okay. So are these opposite angles or are these consecutive angles? Now, these are opposite angles. And opposite angles are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Opposite angles are congruent. So these two equal each other. So we have 4x minus 37 equals, try to think, there we go, equals 49. Okay, so first things first, we're going to get that 37 to the other side. So plus 37, plus 37. All right, so we have 4x equals 6, and that'd be 86. Divided by 4, divided by 4. And so x equals 21.5. All right. Yes, you can have decimals, it's fine. All right, so let's see here. We're going to take the 21. We know what x is now, and we take 21.5, plug it in for x. And so we have 4 times 21.5. Well, that's it. 21.5 minus 3 equals y divided by 5. All right, so 4 times 21.5 is 86. That's what I had over here, right? I got that. Minus 3. So 86 minus 3 is 83. So 83 equals y divided by 5. And if I have y divided by 5, in order to get rid of that 5, I need to multiply both sides by 5. So stick that in the calculator. And 83 times 5 is 415. So 415 equals y. And there are my two answers. All right, let's do one more example. What do we got? Find the coordinates of the intersection of the diagonals of parallelogram element O with vertices there. So those are our vertices. Okay, so we need to find the coordinates of the intersection. So what do you know about the intersection of the diagonals? Well, if you remember a minute ago, we said that the diagonals bisect each other. So they cut each other in half. What that means is where they intersect, that is the midpoint of both diagonals. So all we have to do is use the midpoint formula to solve this. Now, we do need to make sure that we do the right ones. We want to find the midpoint of diagonals, not of sides. So really quickly, I'm just going to draw me a parallelogram. So let's go in. Okay. So L, M, N, O. So that means that my diagonals, remember diagonals go like this. They are not going to connect consecutive sides, consecutive angles. It's got to be non-consecutive angles. So L goes to N, M goes to O. So there's my midpoint right there. Right there. All right. So all I've got to do is midpoint formula for one of these pairs of angles. You don't have to do it for both pairs because they're going to have the same midpoint. So we will use L and N because why not? And hopefully you remember the midpoint formula. If not, I'm going to write it down again. The midpoint is x1 plus x2 divided by 2. And then you do the same thing for y's. y1 plus y2 divided by 2. All right, so we're just going to plug in our x's and y's using L and N. I'm going to ignore M and O. I don't need those. Okay, so L, we have 1 plus N, so 6 over 2. And then we do the y, so we have 4 plus 0 over 2. Well, 1 plus 6 is 7, and 7 divided by 2 is 3.5. 4 plus 0 is 4, divided by 2 is 2. And so my midpoint, the intersection of my diagonals, is at 3.5, 2. All right? And just so you can see this, it will work if we did it with the other ones. Just so you can see, because they have the same midpoint. So 7 plus 0 over 2. And then with M we have 4 plus 0 over 2. And 7 plus 0 is 7, divided by 2 is 3.5. And 4 plus 0 is 4, divided by 2 is 2. And so again, you see, same thing. Because that's where they intersect. That's where they come together. It's the same point either way. All right, so just to recap, the diagonals of a parallelogram will bisect each other. That right there, that is the midpoint of both diagonals. The opposite sides of a parallelogram are congruent to each other. You may have already known that. That's probably review. The opposite angles are congruent. Consecutive angles are supplementary. All right? Consecutive angles will add up to 180 degrees. And the definition of a parallelogram is that it is a quadrilateral and both pairs of opposite sides are parallel, which makes this all work. All right, and that's that. I hope you found that useful. I will see you in the next video.